Input resistance of our Ri in kilo ohms for the amplifier to show at 20 degrees Celsius with the following variables. And to find this, we're going to look at page 132 in the notes linked below the like button. Once at page 132, we can identify that this is a common collector amplifier. Then we're going to look at page about 141, and we're going to get the following equations right here. Now we need to plug in and solve for our Ri. Our Ri is going to be equal to our R pi. We've gone over this previously. It's like our other problems where we use what we have here. We set that our R pi is equal to, we rearrange it a little bit. We have V1 over IB, and then we rewrite our IB to be I over beta, and our V1 is going to be I over GM. Now we can multiply both the numerator and denominator by 1 over I, which is basically by multiplying everything by 1. And if we do this, we are going to get 1 over GM over 1 over beta. Then we can multiply everything by beta. And then we get that our R pi is equal to beta over GM. Now, we don't know our GM. We got to find it. So if we plug in 195 for our beta, what we're going to end up seeing is that I am not great at writing. But our GM is going to be equal to, we know that we have an IC and we have a VT. So we can use what we have right here. We are going to have our I over V1, which is equal to our IC over VT. And so the values that we're going to plug in here are 270 micro over our 26 milli. From here, we are going to get a value, and this value is going to go right here. That's going to be our GM. So once we plug this in, we can solve it, and then we're going to take all of this and we are going to plug it into our R pi because we've solved for it. Then we just plug in our beta and we plug in our RE. And if we do that, we are going to get that our answer is approximately 450 kilo ohms. So Ri is equal to 450, and this is in kilo ohms. Writing it in the answer box would just be 450. Also, just a side note for our R pi, if we're doing the calculations here, this should equal to about 19 kilo ohms. And that's how we go about solving for this problem and anything like it.